As promised, I wanted to go through the algebra for the example we did in class. And so this example is a complicated circuit, and we went through in class and found these four equations using Kirchhoff's rules. So if you need to, you can go back, Lecture 18 over the podcast or lecture notes to figure out how we got those. And that's the first step, and that's the physics. And so now we're moving on to the math, which is trying to solve for these three currents, which is not easy. So this is a particularly kind of nasty one. And so we look here, and none of these equations can you solve for one of the currents right away. Each one has at least two currents. And so what we're going to do is we're going to go through and try to solve in terms of the currents, and we're going to have to sort of plug them back into other equations. So what I'm going to do is I notice here I've got I2 and I3 here, and here I've got I1 and I2. And so my goal is going to be, is right here, I want to solve this one as a function of I3. So I3 equal to a bunch of stuff. And this one I want to solve as I1 equal to a bunch of stuff. Both of those, the only unknown in them left over will be I2. And then we can plug it into this equation. And the only thing we won't know is I2. We can go through and solve that. And that's usually the worst algebra you'll have to do in one of these cases. So let's take this first equation right here. And so I start out with negative 12 volts plus, so negative 12 volts plus 4 ohms I2 plus 6 ohms I3 equals 0. And so I'm going to get on one side I3. So 6 ohms I3, and I bring the two other guys to the other side. So it'll be 12 volts minus 4 ohms I2. And now I'm going to divide everything by 6 ohms. So I get an equation I3. Now 6 ohms divided, or 12 volts divided by 6 ohms is 2 amps. And then minus here it'll be 4 over 6, which works out to be 2/3 I2. So as advertised, we have a I3 in terms of the only unknown being I2. So that's our first equation. Our second one will come from this one over here, and that one's a little bit easier to work out. There's only two terms. And so if I take that one, again, we're solving in terms of I1. I'll get 3 ohms I1 is equal to 4 ohms I2. And if I here then isolate I1, I'll get 4/3 I2. And so now we want to plug both of these guys into this equation over here. And so I'll get 4/3 I2 plus I2 equals I3, which I can plug in 2 amps minus 2/3 I2. And so let's bring this equation over here and start working on this down. So again, just to take the equation over, so 4/3 I2 plus I2 equals 2 amps minus 2/3 I2. So I'm going to bring all the I2s over to the one side. And so I get 4/3 I2 plus another I2 plus 2/3 I2 equals 2 amps. And now I can, the 4/3 and the 2/3 will be 6/3 I2 plus I2, but of course 6/3 is just 2, so 2 I2 plus I2 will give me 3 I2 equals 2 amps. And so now if I solve for I2, I come out just to have 2/3 of an amp. And so that's correct. So that's my first one, so I2. And now that I have that, the rest are in theory just a matter of taking these equations over here. So over here I can get I3, and so I take 2 amps minus 2/3 times that 2/3 of an amp. And when I plug that in, I got something like 0.89 amps. So you definitely want to make sure you go through and check this. And then over here, 4/3 times I2 gave me approximately 1.56 amps. All right, so you definitely want to go through and check this out, but it's a bunch of nasty algebra.